The time period of a geostationary satellite is 24 hours at a height which is equal to 6 RE, where R is the radius of Earth from the surface of Earth. The time period of another satellite whose height is 2.5 RE from the surface will be. So we know the relation between the time period and radius or orbital radius. We know that square of time period is directly proportional to r cube, or from here you can write t is directly proportional to r raised to 3 divided by 2. So you can write the time period of another satellite, I'm just taking it as t2 divided by time period of geostationary satellite t1 is equal to, we can take it as r2 divided by r1 raised to 3 divided by 2. Now the value of r2 is given that second satellite is at a height of 2.5 r from the surface. So if you are observing from the center, so it is going to be 2.5 r plus r, that is 3.5 r divided by the Earth. The geostationary satellite is at a height 6 RE from the surface. So from the center it is 6 RE plus RE, which we can take it as something but 7 r raised to 3 divided by 2. So you can write the value of T2 divided by T1, which is 24 hours, is equal to, this is 3.5 by 7, which we can take it as nothing but 1 divided by 2 raised to 3 divided by 2. Or you can write this as 1 divided by root 2, because raised to 1 by 2 means root raised to 3. So we can write this as basically 1 divided by root 2 into root 2 into root 2. So root 2 into root 2 we can take it as nothing but 2. So this we can take it as 1 by 2 root 2 is a value of T2 divided by 24. So the value of T2 can be written as nothing but 24 divided by 2 root 2, or we can write this is equal to 12 divided by root 2. 12 by root 2 can be written as nothing but 6 into 2 divided by root 2. And if you are cancelling this 2 and this root 2, we can write this is equal to 6 root 2.